Hello, everybody. This is Mr. Couple, and we're doing our first online lesson today. So, if whoever is on right now, if you could say a brief hello to let everybody know that you're here, just say hi to the people who are watching this later on.
Yo,
Hello.
You don't want to introduce who you are? I said, this is Mr. Couple. Who's talking?
listen, if you don't know me, that's your fault.
Wow, okay, thanks, Mayar. But if you guys are going to jump in during the recording and ask questions, the viewers are going to want to know who's talking. So, just if you introduce yourselves now, it'd be awesome.
Um, I'm Mayar.
Thank you.
Hi, I'm Jamie.
Yay, Jamie's here. Anyone else here?
Wait, is it actually just me and Jamie?
Might be who are on voice chat. But that's fine. If it's just the two of you, I am extremely excited about this.
Okay, Jamie, it's me
Yay.
and you, Emmeline, and like Habiba's is gray, not blue, so I don't think she's on.
That's weird.
Yeah, so it
Okay.
might just be you and me, or you and me and Emmeline.
Okay. Well, I'm on a clock. I got 30 minutes, so I'm going to start now. There are
6, sorry.
there are three main ideas that I'm going to teach you guys about today. So here they are. The first is the electrical force is a force that acts between charged objects. It can attract or repel, and you'll remember that I actually started learning about this like a month ago before all the craziness happened. So I'm going to be
this the
talking a
tape?
little bit about that today. What's up?
Was that the tape?
That was the tape experiment that we did. Yep. The second idea is I want you guys to know that charge is a property of matter, and electrons are negatively charged and protons are positively charged. And then the third idea today is I want you to know that the total charge of an isolated system cannot change, and this is called conservation of charge. Let's begin. So the first thing I want to look at is at this picture. So there's this mysterious force, and we did play around with this force in class. So you notice that the water stream is deflected towards the balloon. So instead of the stream falling down, like straight down, the stream actually gets bent to the side. So there must be some force that's pulling that water towards the balloon. What could possibly be causing this? So here's a video which will show this a little bit better. So as we move the balloon towards the stream, you can see the stream is deflected by the balloon. Now, this mysterious force doesn't just attract things, it can also, watch this, this is Bill 9.
Oh, hi. Rub a balloon on your hair and bring it near another balloon hanging by a string.
So you can see that this force can also repel. You guys saw the video, right? And heard it and everything?
There's no sound.
There's no sound. No! Why no
But
sound?
does
Well,
it matter?
no, it doesn't matter. I'll figure out why there's no sound later.
Okay.
Okay, so what we saw here is that this electrical force, which is what we call this mysterious force, it can repel or it can attract. So in the first case with Bill Nye, you can see that this balloon was pushing the other one away. Whereas in this case, the balloon was actually pulling the water towards it. So in one situation, we have a repelling, and in the other situation, we have an attracting. So I want to compare and contrast this electrical force with the gravitational force. So what are some similarities and differences between the electrical force and the gravitational force? So you'll remember that we learned about gravity last semester. So what are the similarities and what are the differences? So if you guys want to chime in here and say what you're thinking.
You know, Jamie, I'll allow you to take this one.
So give me a difference between the electrical force and the gravitational force. So gravity always does something, but electricity can also do something else.
They attract?
Yeah, so with gravity always attracts. So gravity, man, I cannot write at this angle. I wonder if my webcam is even showing up. Let's see. So gravity always attracts. Whereas electricity can do both. The electrical force can repel or it can attract. Well, what are some similarities about these forces? So if you think about it, like if you have like a ball and you drop it on Earth, what will that ball always do? It will fall down to the Earth. It'll be attracted to the Earth. But realize see what's similar about these two forces is that they act without touching. Like these balloons here, the balloons are that force is traveling across space. Same thing here, that these objects don't have to actually physically connect with each other in order to feel this force, that this force can sort of go across space. And so that's what they have in common, is that they both act across distance. And so this is
Is
what we
this
mean
like,
by force. What's up?
is this something that's like with all forces or
Yeah.
just like specifically? Oh, okay.
Yeah, this is with all forces. So there are 4 forces that exist in nature. There's the electrical force, gravitational force, and then there's 2 nuclear forces. And all forces act across distance. The reason is because they're caused by what we say are fields, and these fields go across distance. So it's kind of funny because you think like the only way you get a force is actually like by touching something, by like physical contact. But it turns out that that's not how forces actually work. They actually work across distance without touching. And that's a main idea that we're going to be getting at in a future lesson. I think it'll be next week.
Okay, nice.
All right, so the thing is like what's important to realize like electricity isn't some like bizarre new thing. I mean, it's basically just gravity, but it can also repel. So this leads to my first big question that I want to talk about today is why can't gravity repel? It's like, what is it about gravity that doesn't let it repel? Like if we have this satellite orbiting the Earth, the satellite can only be pulled towards the Earth. Remember, that's circular motion. Like that's a centripetal force pulling the satellite towards the Earth, causing it to go around the Earth instead of falling down to the ground. So we said this back when we learned about gravity. We said any 2 masses what will they do to each other? They will
Attract.
attract. Yep. They will attract each other. So the source of gravity is mass. So anything that has mass is going to be attracted to anything else that has mass. So here's the thing. How many flavors of mass are there? That's like a really weird question. But like, how many different types of mass are there? So like, what kind of mass does the Earth have? Well, it has mass. What kind of mass does the satellite have? Well, it has mass. What kind of mass does your body have? It has mass. So how many different flavors of mass are there? Well, it turns out there's only one flavor. And that flavor, we just call it mass. There's no, positive mass or negative mass. So why can't gravity repel? Well, because there's only one flavor of mass. And so because there's only one type of mass, gravity has to always attract. So the conclusion is that gravity can only attract since there is only one type of mass. I'm trying to draw one.
I
Yeah, what's up?
have a question.
Yeah.
Is flavors like the actual scientific term that
It
you
is.
use? Or...
It is.
Wait, really?
Yeah. That's the actual
Man, I love
scientific term.
physics.
Yeah. Yep, flavor is what we call it. So when you learn about strong nuclear force, there are 3 flavors of what we call color charge, and color charge is what gives rise to strong nuclear force. And the 3 flavors are red, green, and blue. Those are different flavors. So yeah, we use that terminology. I also use it because I think it's cute, and I like to use weird things when I teach. What's up?
What?
Did you say something? You said
No, I didn't say anything. I sneezed.
Okay, that's fine. So why can electricity repel and attract? So in this case, when the balloons are repelling each other, why were they able to do that in addition to the water attracting the balloon? Why is electricity able to do both? So gravity could only do one because there's only one flavor of mass. But electricity doesn't come from mass. Electricity comes from, you guys know?
Medium?
Nope. I can't even draw. Okay, let's see. Electricity comes from a different property. It doesn't come from mass, it comes from a different property, and it starts with a C. Do you guys know it?
Charge?
It's called charge.
Oh, wait, really?
Yeah, and it turns out that there are not just one type of charge, not one flavor of charge, but actually 2. There are 2 flavors of charge. And we talked about this in our last lesson before the craziness. What are the 2 flavors of charge?
Positive and negative.
Positive and negative. And so that leads to this picture, which should look somewhat familiar to what we did with the pieces of tape. So what rule determines whether two charged objects will repel, like they are in this case, versus attracting, like they are over here? What is the rule? I'm gonna let you guys talk about that.
Well, I just need to grab my notes. So
That's fine. So what is the rule that we come up with for saying whether charges will repel or whether they will attract?
And different signs attract.
Yes. So if they're different charges, or we usually don't say different, we usually say opposite. Yep, we say that opposites attract. So that's when you have positive and negative, they will attract each other. And then on the other hand, we say that likes will do what? So
repel.
opposites attract, likes repel. So if we have a positive and a positive, then they'll repel each other. And so this is basically where we left off in the before times, before all the craziness happened. Do you guys have questions about this?
No.
I'm good.
Yeah, this is all pretty straightforward. You probably also remember learning about this in middle school. Okay, so what I was going to do was the next day that I was going to see you after spring break was I was going to pull out this machine. It's called the Graaff Generator. So here's a picture of me messing around with the Graaff Generator. So the way this machine works is there's a belt inside of it. So you can see this belt here. And what the belt does is it turns around this little piece of cloth, and the belt actually rubs around that cloth. I guess it actually goes the other direction, if you can see on this picture over here. So the belt comes down this way and it rubs against that cloth. And then as the belt and the cloth rub together, some charge gets transferred from the cloth onto the belt. And then the belt carries those little charges all the way up to the top of this sphere up here. And then so this sphere becomes positively charged. And so when I touch the sphere, those positive charges travel into my body, and my body becomes positively charged. And then all of my hair becomes positively charged. And what do like charges do to each other?
Repel.
They repel each other. And so that's what's causing my hair to get repelled all over the place. And so I was going to show that to you guys in class. Unfortunately, you just have to watch this picture of me doing it. But you can see I'm in my classroom, like, how cool is this? I actually did this. And then I was going to do this spectacular demonstration, which I can only show you guys a video of. So here it is. Let me pause it. So I got a bunch of those little paper scraps on top of this Graaff generator, and I'm going to turn it on and watch what happens.
Oh, sick.
That's so cool.
And it fills the room with confetti.
So I have a question.
Yeah.
So does this mean that electricity is like a friction based?
It's
Or
not
like a friction? Is it?
So it's not friction based, but you're on the right track. So this is how you charge objects. So when you rub two things together, charge from one object can rub off onto the other object, and then they can become charged. I need to close down. I got a program going crazy over here. Mr. Johnson's trying to chat with me. Okay, sorry. But yeah, so friction is what allows things to become charged. And so that's what you're seeing is like the belt rubbing against there. It's stripping charge off the cloth. And actually, it's stripping charge off the belt and putting it onto the cloth. And so we're going to talk a little bit more about this when we get to the conservation idea. But yes, friction is what you need to get things charged up. So if you think about lightning, so what's the origin of lightning? So our best understanding of it, let me do a Google search for you guys real quick. So lightning cloud illustration, maybe. So this is just to answer your question. This isn't going to come up.
That is very educational.
Lightning charge animation. Let me see if I can find it. There's one that NASA puts out. This is it. This is the one right here. So I'll zoom in on that. If it'll let me, it won't let me.
So
That's not even, this is the one I wanted. Okay, here we go. So I got this. Open image, a new tab. Okay. So this is what's going on inside a lightning cloud. So you have frozen water, that's those little snowflakes. rising up because frozen water is less dense than liquid water, and the liquid water is falling down. And so this is what we think. We don't actually know. Like it's there's not a lot really known about lightning. Like it's a big kind of mysterious topic, but what we think happens is the frozen water, the ice in the cloud, rises upward, and then the liquid water falls down, and they bonk into each other. So before they bonk into each other, they are neutrally charged. They have the same amount of positive and the same amount of negative charge in them. But when they bonk together, that friction, that rubbing together, transfers charge, negative charge onto the water droplet, and then that means the snowflake ends up having a positive charge left over. And this ends up creating the charge separation in the cloud. So when you look at this across the entire cloud, all this positive charge rises up to the top and a bunch of negative charge rises down to the bottom. And then this charge separation is what gives rise to lightning. So asking, is electricity friction based? It kind of is. Like friction is how we actually get objects to have a charge, but it's not really related to friction in the sense that it's not like friction is electricity. It's not quite that. So does that answer your question?
Yeah.
Cool. That was a good question. All right, let's see where we were. Oh yeah, so that was the Van Graaff generator. So this is as close as I can get to actually like doing the demonstration with you guys. So I'm sorry you don't actually get to see it in person. So you'll have to remind me when y'all take IB physics to bust it out and show it to you for reals. All right, so that was element one. So element one was the electro force is a force that acts between charged objects. It can either attract or it can repel. Okay, so now we're going to talk about what is charge. So this is the origins of charge. So we're talking a lot about this thing like charge. Oh, things that are positive and things are negative charge. What is charge? Like, where does it come from? What is it? And so what we say is that charge is a property of matter. I know that it seems like really like silly, but that's literally the definition of charge. Charge is a property of matter. It's a really vague definition because we really don't know what charge is. We just know that it exists. It's a property that certain things have. More specifically, you can say it's a property of particles. So let's look at this picture. This is a picture of an atom. Do you know what these different particles in the atom are called? So let's start with these guys here. What are those particles called?
Neutrons.
They're the ones that zoom around the outside of the atom. They like they fly around.
Electron.
Yeah, that's the electron. Then in the nucleus of the atom, there are two additional charges. So there's this blue one, and then there's this red one. Maybe I should use blue for the blue and then red for the red. Oh, I can't see blue on there. I'll just use pink for both. Okay, so the blue one and the red one. We'll call the red one, well, this is the neutron. So the blue one is the neutron. So then what's the red one called?
Proton.
That's the proton. So this is what atoms are made of. And so we say that charge is a property of particles. So maybe you guys already know this. Like, what charge does an electron have?
Negative.
Electrons have a minus charge, yeah, negative charge. Protons have
Positive.
positive charge, and neutrons have,
No charge.
Neutral.
they have no charge. They're neutrally charged. You got it. And so that's where charge comes from. So when you say what is charge, where does it come from? Well, we don't really know what it is, but we know that it's this property that particles have. Electrons have a minus charge, protons have a positive charge, and neutrons have no charge. So that's where charge comes from. So now think about, why is it that when two things rub together, why does charge transfer from one to the other? Well, look at what's on the outside of the atom, negative charges. So if you rub two things together, it would make sense that electrons from one object can rub off and go on to the other object. And so that's the whole idea with friction coming in, is if you rub atoms together, electrons can kind of fall off. They can like scuff off the atom onto the other object.
So I have a question.
Yeah.
Going back to the picture of the atom.
Mhm.
If we're going with the idea that like opposites, does that mean that like protons and neutrons are opposites, or?
Right. So you embraced upon a really important idea, is that if all of these protons are positively charged, then aren't positive charges supposed to repel each other? So what's going on there? That's a really advanced question. The answer to it is there's another force acting in the nucleus. So there's another force in there. It's called the nuclear force, and the nuclear force acts on the nucleus, and the nuclear force is an attractive force that acts between protons and neutrons. And so that force actually holds the whole nucleus together. The nuclear
Yes.
force is the strongest force in nature. It's ridiculously strong, but it's really, really short range. The nuclear force is actually was going to be the topic of nuclear physics, but there's obviously not enough time for me to teach you guys about nuclear physics anymore. But yeah, that was a good question, Mara. So does that help answer what you were going to say?
Yeah, so like the general idea isn't that neutrons are charged like oppositely to protons or electrons.
Right. It's a completely different property called the nuclear force that acts between protons and neutrons. That
Okay,
was the
great.
strong force I was telling you about with the color charge, or like with the red, blue, and green positive, different, not positive, but different color charges.
Yeah.
Yeah,
Okay.
so there are two different things going on inside the atom, and it's actually like really complicated. But yeah, you touched on a really advanced idea is like protons, if it was just protons in there, they would repel each other and no atoms could exist. Well, beyond just having one proton. The reason why atoms can have more than one proton is because there's another force, the nuclear force, that's holding the atom together. Just checking on my
So,
time. I got 10 minutes. Yep.
without the nuclear force, protons and neutrons wouldn't attract.
That's exactly correct. Yep. So you can think of the nuclear force like these short range hooks that where protons and neutrons get close enough, they can stick together. But if they're far apart, they don't stick together. They only stick when they're close because the strong nuclear force is a very short range. And so that's why the nucleus of an atom is so tiny, because the force that holds the nucleus together is this crazy small force.
Like
Now,
glue.
it is like glue. So now the electric force has an infinite range, like gravity. Like electric force can go for infinite distances. And so that's how you build molecules, or that's how you can get atoms to stick together and build up like, strands of DNA or things like that. And that's why electricity is a really big idea to understand going into chemistry. And so that's why I wanted to make sure that you guys got this knowledge, because you're going to need it when you get to chemistry next year. Cool?
Yeah.
Okay, I want to show you guys this picture. This is way beyond anything that you would ever actually try to teach in an intro physics class, but I wanted to show you guys a little bit deeper of what's actually going on. So this picture is called the standard model of elementary particles. An elementary particle is the smallest particle that we know of. Like there's nothing smaller that it's made of. That it's fundamental. Like there's nothing inside of it. So it turns out that protons and neutrons, they're not elementary. Because if you look at this picture here, protons and neutrons are actually made of these three smaller particles. And these smaller particles, we call them quarks. And so that's these purple particles on this list here, the quarks. So there's actually 6 types of quarks. There's up, down, charm, strange, top, and bottom. So this picture shows all the elementary particles that we've discovered so far. As far as we know, everything in the universe is made from these particles. So what you'll notice is that all these particles, they have 3 properties. They have mass, they have charge, and they have spin. And so don't worry about spin. Spin is a pretty advanced quantum mechanics idea, but you can see focusing there is mass and charge. So all these particles, they all have a certain mass and they all have a certain charge. And so when you think about what is charge, well, it's kind of the same thing as mass. Like what is mass? You can't really answer that question, just like you can't really say what is charge. It's just a property that these particles have, and we know that it exists because of how they behave and how they interact with each other. And so that was just a little bit of advanced stuff there. So my question is, how do you build an atom? So how do we make an atom? Well, to make an atom, we need neutrons, protons, and electrons. You'll notice that the electrons are already on here. They're in this category called the leptons. So the electron is right there. But where do you get protons and neutrons? So to make a proton, you actually have to take 2 up quarks and a down quark. So you have to take 2 ups and a down. So these 3 particles create atoms. All those other particles over there, those are all exotic particles that you do not find in normal matter. And then what's really cool, I'll just show you this really quick. So if you look at what the charge of an up quark is, it's a positive 2/3. So the up quark has a positive 2/3 charge. And the down quark has a negative 1/3 charge. So if you go over here to a proton, you're like, all right, so the up quark was a positive 2/3, positive 2/3, and a negative 1/3. So what happens when you add all those up? So if you go 2/3 plus
You get 1.
2/3 minus 1/3, you get 1.
1.
And so the charge of a proton is positive 1. But if you look at a neutron, so the neutron has, let's use green. So the neutron has negative 1/3 from the down, negative, I cannot see, green on green, negative 1/3 from the down, and then positive 2/3 for the up. So here you'd have 2/3 minus 1/3 minus 1/3, and that would actually give us,
0.
you get 0.
0.
And so that's how you can see that the proton and the neutron have this is called the net charge. So the total charge of a neutron is 0. It's made of things that have charge, but there's an equal amount of positive and negative charge, so it ends up balancing out to having a 0 total charge, whereas a proton ends up having a net charge of 1. There's a lot more physics going on there, but I'm not really going to get too much into it. But the main idea I want you guys to get at is that charge is a property of matter. It's just a property that these particles have. And so asking what is charge is very similar to asking what is mass. The answer to both these questions is that they're properties of matter. So that's charge.
Is there anything else, or can I ask a question?
Is there, what do you mean? Yeah, you could ask anytime.
Oh, okay. So is the nuclear force a product of the electrons, protons, and neutrons, or is it something that exists beforehand that allows an atom to exist?
Yeah, it's a good question. So the strong nuclear force is the force that acts between these particles. So quarks are strongly attracted to other quarks, and that's called the strong nuclear force. So since protons and neutrons are both made of quarks, they will both attract each other. But
Okay,
you'll notice
thank
that it's not, because electrons are a completely different category of particles. They're called leptons. They don't interact with quarks through the nuclear force, because the nuclear force only acts here on quarks, but the electric force acts on anything that has charge. So as long as there's a charge, the electric force can act between those things. But if you look at these guys over here, these are called the bosons. The bosons, they don't have charge. So this one does. But a lot of these bosons don't have a charge. And if it doesn't have a charge, then it can't act through the electric force. If it's a quark, it acts through the nuclear force. And if it has mass, then gravity can act on it. So that's the basic
Okay.
idea.
Thank you.
Yep. Okay, so then there's one more thing I want to talk to you guys about, and that's the idea of conservation. So this is like a really simple idea since we've studied conservation in the past. I have about 4 minutes to wrap things up here. So I wanted to just mention, you guys have probably heard of this before. You've probably heard of conservation of mass. You've probably heard this in a middle school science class, or maybe even elementary school science class, where a teacher might have said, mass can't be created or destroyed. So I looked this up on Google, and this is what it showed me. It says the law of conservation of mass. It says that for any system closed to all transfers of matter and energy, the mass of the system must remain constant over time. Usually people say mass cannot be created or destroyed. You've probably heard of that before in science. Yes? No?
Yes.
Yeah.
So what about conservation of charge? Is that a thing? So if I search for conservation of charge, what will I find? So it turns out it is a thing. So you can have conservation of charge. Why wouldn't it let me? I'm trying to take a picture of this. Let me see if I can grab this picture. Good enough. All right, so conservation of charge is also a thing, just like conservation of masses. Yeah, I know you took the picture. Thank you. Oh my gosh, that was huge. All right, so charge conservation. I don't know why I thought this would be cool to like have you guys watch me do that, but there it is. So charge conservation is also true, and it basically just says that the total charge of an isolated system can never change. So if you have, so here's the situation on here. If you have a person who's rubbing a rod with a piece of animal fur, and they pull the rod out, and suddenly it's negatively charged. Well, the charge of the whole system has to stay the same. So what was the charge to begin with? In this first situation here, what total charge did we have? Do you see any negatives? Do you see any positives? So the total charge here is, what's the total charge here? I lost you guys. What's the total charge here?
I didn't hear what you asked.
I'm asking what the total charge here is. So this guy has this rod and this fur, and he's brought them together. So what's the total charge there? Remember, they're made of atoms. So what's the total charge in this box? See, he pulls it out. He pulls the rod out of the fur, and suddenly the rod is now negatively charged. But before he pulled it out, what was the charge of the system?
Positive.
Nope, it was 0. There is no charge. He pulls it out, and now part of it is negatively charged. So the idea is like, before you rub things together, they're not charged. They don't have a charge. There's zero charge. But then suddenly you pull this rod out of the fur, and oh my gosh, it's charged. What the heck? Well, why is that? How is that possible? Well, total charge has to stay zero. So what has to be happening down here with the fur? If the rod became negatively charged, what has to happen to the fur?
They rubbed each other.
And then what charge is going to be left on the fur?
Positive.
It's going to be positive because it has to cancel out and get you back to zero because the total charge can't change. So that's the idea of conservation of charge. So when a rod is rubbed with animal fur, the rod becomes negatively charged. Was this negative charge created or was it always there? And the answer is it was always there. So when you look at that piece of fur, I'm going to try to draw the fur. When we look at that fur, what was actually happening there was it had a bunch of negatives, but it also had a bunch of positives, and it had just as many negatives and just as many positives. But then what happened was when you rub the rod grabbed all those negative charges, and then the fur had fewer charges left over. It still had all those positive charges, 1, 2, 3, 4, 5, 6. That's my timer. And then it only had, how many do I have? 3 negative charges left over. So the rod ends up becoming negatively charged, and the fur ends up having a positive 3 charge because there's now, it's 6 minus 3. 6 minus 3 equals 3. Well, anyway, so that's the conservation charge. The total charge has to stay the same. I got to stop the video now because I'm only supposed to teach you guys for 30 minutes, but I'll leave with this question up here for you guys to look at. It says, the picture shows 3 different configurations of charges inside a rectangular object. Identify the charge of each object. I'm going to end it there. So I'll see you guys
Wait,
later.
what's your YouTube channel?